At the dawn of the 20th century, humanity faced two silent terrors: hunger and war. Into this world stepped Fritz Haber, a chemist whose work would touch every farm and battlefield on Earth. His discoveries promised bread for billions, yet also unleashed new forms of mass death. This documentary explores how a single brilliant mind embodied the triumph and tragedy of modern science, forcing us to confront uncomfortable questions about responsibility, loyalty, and the cost of progress. Fritz Haber was not a cartoon villain, nor a misunderstood hero. He was a deeply human figure, driven by ambition, patriotism, and belief in science as the ultimate problem solver. To understand him is to understand the age that produced him, an era when chemistry promised salvation and nations demanded absolute devotion from their scientists, no matter the moral cost. The enigma of Fritz Haber is central to the foundation of the modern era. At present, approximately half of the nitrogen within your body originates from a method he developed. However, his legacy is also deeply tied to the invention of chemical warfare and mass industrialized killing. These conflicting aspects are not coincidental. They stem from decisions made under duress, influenced by historical context and individual beliefs. This story is not just about one man, but about the role of scientists in society. What happens when knowledge becomes power, and power demands obedience? Where does personal responsibility end when a nation is at war? Fritz Haber's life forces us to sit with these questions, even a century later. From humble beginnings to international fame, from Nobel honors to moral condemnation, Haber's journey is a dramatic arc worthy of tragedy. Before poison clouds rolled across battlefields, before fertilizer reshaped global agriculture, there was simply a gifted boy in Germany, eager to prove himself through chemistry. To truly grasp Fritz Haber's impact, we must begin at the beginning, with his origins, his education, and the scientific world that shaped his ambitions. The seeds of both creation and destruction were planted early. At the start of the 20th century, Germany was a country striving for industrial and military supremacy, driven by a strong belief in science. Among its advancements, chemistry stood out as the pinnacle of German ingenuity. Haber was destined to emerge as one of its most brilliant and divisive figures. This is the tale of how nourishing the world and contaminating it unfortunately became intertwined as part of the same scientific heritage. Fritz Haber was born in 1868 in Breslau, then part of Prussia. He grew up in a Jewish family that valued education and discipline. His mother died shortly after his birth, a loss that shaped his emotional distance throughout life. From an early age, Haber sought validation through achievement, especially in the hard certainties of science. As a young man, Haber struggled to find his place. He tried business, but failed. Only in chemistry did he find both structure and purpose. German universities at the time were global leaders, and Haber trained under some of the finest chemists in Europe, absorbing a culture that prized results over reflection. Haber converted from Judaism to Lutheranism in 1892, a decision motivated less by faith than by career pragmatism. In Imperial Germany, social and professional advancement often demanded conformity. This choice haunted him later, especially when the nation he served ultimately rejected him. By the early 1900s, Haber had obtained a position in academia and wed Clara Immerwahr, who was also a chemist. Clara was among the first women in Germany to receive a doctorate in chemistry. However, their marriage was strained, characterized by opposing values and Haber's relentless ambition. Germany faced a looming crisis: food scarcity. Natural nitrogen fertilizers were limited, and population growth threatened famine. Chemists worldwide raced to solve what seemed impossible: how to pull nitrogen from the air and turn it into usable fertilizer. Haber saw an opportunity for glory. Nitrogen makes up most of the air we breathe, yet it is chemically stubborn. Breaking its triple bond requires extreme conditions. Many had tried and failed. Haber believed that with enough pressure, heat, and catalyst, chemistry would yield. In 1909, Haber succeeded. Working in his laboratory, he demonstrated a method to synthesize ammonia from nitrogen and hydrogen. It was a scientific breakthrough with staggering implications, though scaling it up would require industrial muscle. Industrialist Karl Bosch transformed Haber's experiment into a factory process. Together, their work became known as the Haber-Bosch process, an invention that would reshape civilization itself. With the ability to produce ammonia on an industrial scale, Germany obtained not just sustenance, but also explosives. The very same nitrogen that supports agriculture can also fuel conflict, a dual purpose that quickly turned disastrous. The Amber-Bosch process enabled the mass production of synthetic fertilizers. This led to a significant rise in agricultural outputs. Predictions of widespread starvation were no longer a concern. Today, historians estimate that about half of the global population depends on food grown using nitrogen-based fertilizers, created through Haber's method. This was far more than a small advancement. It was a groundbreaking transformation. For the very first time, humanity successfully altered the nitrogen cycle, freeing agriculture from its reliance on scarce natural resources such as guano and manure. The capacity of civilization to sustain itself grew significantly. Haber became internationally famous. He was hailed as a savior of humanity, a man whose chemistry conquered hunger. Universities, governments, and industries clamored for his expertise and endorsement. Yet even in peace, the shadow of war loomed. Synthetic ammonia also meant synthetic nitrates, essential for gunpowder and explosives. Germany, cut off from natural resources during wartime, could now sustain prolonged conflict. When World War I erupted in 1914, Haber did not hesitate. A staunch nationalist, he believed scientific service to the state was an absolute duty. For him, chemistry was a weapon like any other. Haber was appointed head of Germany's chemical warfare program. His task was clear: break the stalemate of trench warfare using science. What followed would forever stain his legacy. Many scientists refused to participate in such work. Haber aggressively recruited, arguing that ending the war quickly would ultimately save lives. This reasoning, deeply flawed, guided his actions. The boundary between nourishing the world and using science as a weapon had been breached. Haber moved forward willingly. The next phase of his career would make him infamous, both during that period and in the current day. On April 22, 1915, at Ypres in Belgium, the Germans released chlorine gas toward Allied trenches. Haber personally oversaw the operation. As the greenish cloud rolled in, soldiers choked, panicked, and died in agony. Chemical weapons violated existing conventions, but enforcement was weak. Soon all sides embraced gas warfare. What Haber unleashed could not be contained. At home, tragedy struck. Days after the Ypres attack, Clara Immerwahr took her own life, reportedly devastated by her husband's role in chemical warfare. Their relationship had collapsed under the weight of his choices. Haber departed almost at once for the Eastern Front. His way of coping with personal sorrow was to completely throw himself into his work, a habit that shaped his entire life. The war ended in defeat for Germany. Chemical weapons had not delivered victory, only horror. Millions were dead, and the world recoiled at the methods used. In a bitter irony, Haber was awarded the 1918 Nobel Prize in Chemistry for the ammonia synthesis. The award was presented in 1919 amid international outrage. To some individuals, he was regarded as a savior. To others, he was considered a war criminal. Haber asserted that he had served his country with honor, separating his scientific achievements from moral responsibilities. This separation would soon collapse under the weight of history. The world that Haber had a hand in shaping was beginning to oppose him. After the war, Haber continued his research, including pest control using cyanide-based compounds. One such line of work led to Zyklon B, a pesticide later used by the Nazis in extermination camps after Haber's departure and death. Haber neither designed nor sanctioned its genocidal use, but the association remains unbearable. Science, once again, proved indifferent to intent. In 1933, the Nazi regime dismissed Jewish scientists from public positions. Despite his loyalty and conversion, Haber was forced out of the institute he had built. Exiled and heartbroken, Haber left Germany. The nation he served rejected him completely. He died in 1934 in Basel, Switzerland, intellectually restless to the end, but spiritually exhausted. His family suffered enormously under Nazism. Several relatives, including descendants, were murdered in the Holocaust. A minor, cruel irony. Haber did not live to see the final misuse of the chemistry made possible during his time, but his contradictory legacy was already firmly established. The effects of his actions, both positive and negative, persisted in shaping the course of history. Fritz Haber's story forces us to ask not just what science can do, but what it should do. Today, the Haber-Bosch process feeds billions. Without it, modern civilization as we know it might collapse. For this alone, Fritz Haber is etched into human history. Nonetheless, the 20th century is also defined by chemical warfare and large-scale industrialized slaughter. Haber's life illustrates that progress in science is always accompanied by moral considerations. He believed loyalty to the state justified everything. History has judged that belief harshly. The story of Fritz Haber is not a critique of science itself, but a call for ethical accountability from those who apply it. Progress without conscience is perilous. In remembering Haber, we remember both the power and danger of human ingenuity. His influence endures in every dish and in every cautionary tale about the morality of science used to serve authority. Fritz Haber fed the world. He also helped poison it. Holding both truths is the only honest way to remember him. This emphasizes the significance of understanding and the outcomes of disregarding its ethical value.